Alright, here's our video for our practice exam 1. Now this one is not graded, but I do want you to go over it because it is a very important one to go over. It's got some really good questions. The one that's due this week, that's done through It's Learning, will be graded, so make sure you do a good job of that. And like I said, it is done through It's Learning. Alright, so let's go through this one. On the dots below represent basically your free body diagrams. The dashed lines are drawn at the same time. Draw and label the forces not coming on the block, up the ramp and down the ramp. Now, it is true you will not have to do this. However, and you'll see this on your practice test, you will have to describe it. So how would I describe this? Well, that's my force normal. And I would say my force normal is coming out of the center of the block, or the ball, the block, and it is perpendicular to the surface. That is my force friction, which is parallel to the surface, going down the ramp to the left. And there is my force gravity, which is going straight down from the center of the block. Now, that's for up the ramp. For down the ramp, I have my force gravity going straight down again. I have my force normal going perpendicular. That's important to state. That's perpendicular to the surface of the ramp is my force normal. And then going up the ramp parallel with it is my force friction. So these are my two different free body diagrams. Now, the block takes time t up to slide up the ramp and distance x. The block then takes time t down to slide back down the ramp to the bottom of the ramp, which it has a speed of vf. Is t down greater than, equal to, or less than t up? Now, be careful here. This is very tricky. In a clear, coherent paragraph length response, you may have to contain figures and/or equations to explain your response. If you need to draw anything other than what you have shown in part A to assess in your response, use the space below. Do not add anything to the figures in part A. So right there, they're telling you that you are going to want to talk about part A. Okay? Second thing, paragraph length response. Now, when I wrote my answer and then I checked the answer they had, mine's a little different than the AP answer, but it's still correct. I actually called and checked this out with other people. My original answer, which is 100% correct, would not have gotten full credit. And I'm going to show you where that was and why. But the fact that they give you this hint of part A. Now, when they say paragraph, you need to talk about everything you can. That is the key to a paragraph as opposed to briefly explain. Briefly explain should be done in 1 to 2 sentences. Paragraph, 3 to 4 sentences, but you've got to talk about everything. Talk about the accelerations. Talk about the velocity. Talk about everything you can. But let's take a look right here at this part. Now, when you're pushing up the ramp, right? Tell me about the force to go up the ramp. The force to go up the ramp compared to the force coming down the ramp, in a sense. The force going up the ramp has to overcome two things, friction and gravity. The force going down the ramp has to overcome what? Friction, but not gravity. So you've got a bigger force to push up and less of a force to push down. If you have a bigger force, you have a bigger acceleration. The time to t down is much greater than the time for t up. Look at this again. When this is sliding down, right, friction is going to be slowing it down. Now, let me show you how I did mine. The magnitude of the net force will be greater going up. Has to be. You have to overcome more. Because although friction force changes, the part of gravity pulling the block down does not. See the free body diagram. That's what I just talked with you about. The larger force will create a larger acceleration up the ramp. If the acceleration is greater going up the ramp, then the V initial must be greater than V final because it has to overcome friction and gravity slowing it down. Now, we're not talking about final up here, we're talking final here. Now, when you throw a ball up in the air, yes, that's different, but we're talking about throwing up something that has friction on it and gravity acting on it. Well, what about the air friction? No, not the same. So, the V naught must be greater than the VF. So I've got to give it a bigger oomph to get up over this. Why? Because to get up over this, it's got to be going faster because it has to overcome gravity and friction. But when it starts going back down, it does not have to overcome gravity. Gravity is actually, in a sense, helping it. So it's not going to have the same amount of oomph in a sense that it had here. If the V naught is greater than VF, and the distance is the same, right? So my VF must be greater than my V naught must be greater than I've got to push it with more oomph to get it up there, and then when it comes back down, it does not have to have the same amount of speed it hits. Now these should be technically absolute value signs if you want to get technical. But if my V naught is greater than my VF and the distance is the same, the V at the top of the ramp we know is 0, and we start at t equals 0 using the equation delta x equals VIT plus 1/2 AT squared, then the first V1t is 0. Right? So this V1t here has to be 0 because the time is either 0, right? So the time is either 0 or up here, your velocity up here, if you start that being your final velocity, is 0. Then t equals 2 delta x over a. So stay with me here because this is a little different of explanation. I actually kind of like this one. This is my equation I'm using, right? So if my initial velocity has to be greater, I mean, if I look at this has to be 0 no matter how I cut it. Either it's here it's 0 because the time is 0, or up here it's 0 because the velocity right here is 0, or you could say time here is 0. So my t equals 2 over delta x over a. Well, we just agreed, hopefully we agreed, that the force that I'm pushing up with has to be greater when it's going up the ramp than the force that's pulling it down. And it has to be because you're overcoming friction and you're overcoming gravity. But the force going down only has to overcome friction. It doesn't have to overcome gravity because gravity is the force actually pulling it down. So it's going to have a smaller force, hence a smaller A. And if this is a larger A, then my time to come back down has to be greater. Basically, that's 1 over A. As A increases, T decreases. So since I have a larger acceleration here, my time has to decrease according to this. So that means if I have a smaller acceleration, I have more time. Now, this is the part where, in my opinion, I didn't think I needed this part. This part where I talk about this. If the acceleration is greater going up the ramp, then the V naught must be greater than VF because it has to overcome the friction of the gravity showing down. If the V naught is greater than VF and the distance is the same, the V at the top of the ramp is 0. We start at t equals 0. We use this equation. Now, I could have explained this a little differently, but this V part I don't need, and I show that with this equation. I don't care about the velocity. I know that the force pushing up and the force pulling it down the ramp are different. I know that this force is greater than the force pulling it down the ramp. And I show that it doesn't matter with this piece because we start at 0 and we know that this velocity up here is 0. So either way, I don't think I need this part. So then that's when I talked to some people and they said, yes, you are 100% correct. But because it asks for a paragraph, you have to mention velocity. Now, I could have mentioned this basically right here. If your V naught is greater than your VF and the distance is the same and the velocity at the top of the ramp is 0, well, I could have worked that into another way of talking about how that the velocity coming down this way and the velocity going up this way are going to be different times. I could have used a different equation actually. But notice, ultimately, this right here, this whole sentence about the velocities being different is completely irrelevant to my argument. Just because of the way I argued it. I could have changed the bottom of this argument to include it. I didn't. But I would have lost points because they wanted you to talk about the acceleration. They wanted you to talk about the force. They wanted you to talk about the velocity. And they wanted it all together in a nice coherent sentence. So although I would have left this out, I would have lost a point. So if you see paragraph, you want to deal with as much as you can. Even if you think it's not relevant, doesn't matter. Put it in there. Talk about it. I know that sounds weird. And if you're confused on this one, I'm happy to go over it with you on the Q&A. I can even tell you exactly what the AP answer was for this one. But I wanted to go over how I went over it and how I would have lost a point because I would have left this whole part off about the velocity because it doesn't matter in my argument because I'm only talking about acceleration and force. And that's it. That's why it was a short question. All right. Have a good day.